Let's take a look at graphing systems of inequalities. We have a system of inequalities right here that we're going to graph. We're going to graph the first one, see what it looks like, then graph the second one and see what it looks like. Where the shading for these two overlap is where our solution is. So for this particular one here, it's in standard form, so I'm going to use the intercepts in order to graph it. It's also going to be a dashed line because I have a less than. So let's first find our x-intercept. For our x-intercept, y equals 0. And so we're going to plug in 0 and get 4x minus 2 times 0 equals 8. So 4x equals 8. Divide both sides by 4, and x equals 2. So our x-intercept is at 2, 0. Let's go ahead and put a point there. Now let's find our y-intercept. When we do that, x is going to equal 0. Replacing x with 0, we get 4 times 0 minus 2y equals 8, or negative 2y equals 8. Divide both sides by negative 2, and y equals negative 4. So our y-intercept is at 0, negative 4, which is right here. Now we're going to connect those with a dashed line because that was a less than symbol. So we'll go and connect these with a dashed line. Now we need to notice also what side of this dashed line needs to be shaded. So we need to test a point. How about if we test our origin 0, 0, because that's the easiest to plug in. So let's test the point 0, 0 in this equation. That would be 4 times 0 minus 2 times 0 less than 8, or 0 less than 8, which is a true statement. And since that point is located on this side of the line, this side is true. So if we were going to shade it, we would shade everything up in this direction here. Let's keep that in mind while we graph the other one, because we're going to want where the overlapping shading would be. And we know this one's shaded on this side, so the overlap has to be somewhere up here. So now we're ready to graph our second equation. Now our second equation is going to be a dashed line also, because that's a less than symbol. So let's go ahead and graph using intercepts again, because this is in standard form. Our x-intercept will have a y equal to 0. That's going to be x plus 3 times 0 equals 6, or x equals 6. That's the point 6, 0. So we're going to place a point on the graph at 6, 0. Now let's find our y-intercept. So on our y-intercept, x is 0. So plugging in 0 here, we get 0 plus 3y equals 6, or 3y equals 6. If we divide both sides by 3, y ends up equaling 2. So we have the point 0, 2. Well, the point 0, 2 is right here. Now remember, we need to connect these two with a dashed line. So we're going to make a dashed line all the way over here. Okay, so now we have our dashed line. We need to test out a point. And for this particular line right here, 0, 0 would be on this side. Let's test that point out and see if it works. If it does, since we shade this side of the first line, if this is true, we'll shade this section here. If it's false, we'll shade that section up there as the overlap. So we're going to test out 0, 0 by putting 0 in here and here. We have 0 plus 3 times 0 less than 6, or 0 less than 6. Well, that's true. And 0, 0 was on this side of that, and it was true. So since that was true, this side would need to be shaded. all the way down here for the second one. But notice the only overlap would be right here, so we don't want to shade here or here because the solution to this system is only the overlap. So this section will be where our overlap is, and that is where all the solutions for that system go. We have a dashed line on this side, a dashed line on that side, and everything shaded in between.